check. 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 I hope. Yeah, cake it. Super. Okay. Hello, people. Hi everyone. Hi those who are watching live and those who are watching the recorded one as well. Hello. Hi. Safura. Hi. See, I was supposed to take class on Saturday and then I was not available அன்னைக்கு அதனால I had to take some time. நேற்று வந்து வினோத் எடுத்த class from Stanley. Okay, are you guys excited? Thermodynamics. Okay, as usual, before starting our class, whatever you do, I'm supposed to do, அதுக்கு முன்னாடி I should make a separate slide here on. Ask me your NEET related doubts. Okay. Max to max in class one I'll finish it in 2 hours. Okay, அதுக்கப்புறம் 6 o'clock you take a break and then come back at 6 p.m. to for the next class. Okay, fine. So yeah, I'll be able to finish it நினைக்கிறேன். Ask me any questions based on for your preparation. See, இன்னைக்கு வந்து it's March 9th. Okay, you have not even 2 months in your hand. Okay, yeah, so if you aren't serious இப்போ வரைக்கும் இதுக்கப்புறம் சீரியஸ் ஆக ட்ரை பண்ணிக்கோங்க because இதுக்கப்புறம் you must be serious. And session ஆரம்பிக்கும் முன்னாடி I need to tell you a few things. Okay, one, all the everything that I'm going to discuss today from this chapter thermodynamics, not everything may not come in the exam. hardly one question comes, okay? One illa rendu question varum thermodynamics la. And this chapter has a lot of implication, okay? Laws of thermodynamics are like are like foundations of how stuff work in our universe. So there are derivations, okay? Derivation எனக்கு பண்ண தெரியும். I can teach you as well, but you are not going to become a scientist, okay? Physics major பண்ணிட்டு PhD பண்ணிட்டு you're going to do some research and all. So for the sake, because you have just one month and 2 3 weeks, hardly 3 weeks, I would like you to memorize those few formulas, so because you can't understand it, okay? If you want to understand it, then you'll have to derive it, but அது அவசியம் இல்லை. So okay, how to retain what we have studied. Revision, okay? No matter what you do, I brought to show, I got this note, okay, to show you. This is my 11th standard use for note. I have biology and chemistry there. If you see, I wrote, this is your entire this entire 3 pages. I wrote whatever I missed in my in the chapter on the plant kingdom, okay? Plant kingdom chapter entire thing I wrote it in 3 pages, okay? So அதுவும் வந்து 3 pages include all those which I keep forgetting. எக்ஸாமில் வரும்போது எனக்கு ஆன்சர் பண்ண தெரியாமல் இருக்கும், அந்த மாதிரி கொஷின்ஸ் அண்ட் ஆல் I put it, I write it here and I keep it here, okay? And then இன்னும் கொஞ்சம் போனீங்கன்னா you have chemistry. இங்கே கெமிஸ்ட்ரி வந்து entire qualitative analysis I wrote in 1 page. I just wanted to show you. இதெல்லாம் வந்து this is what I did during for my revision. When I write stuffs in the மாதிரி and when I see it again, எப்பயாச்சு I easily retain stuff because நான் என் கையில் எழுதுனது ஒன்று. 2, it composes of everything that I previously didn't remember or I made mistakes in, okay? 2, 3, I had this book always with me, so it was very helpful. Everything was in this. I had biology and chemistry full-ஆவே இதில் இருக்கு. நிறைய பேருக்கு. So yeah, so to retain what we have studied, you must recall stuff frequent-ஆ நீ படிச்சுட்டே இருக்கணும், ரிவைஸ் பண்ணிட்டே இருக்கணும். frequent-ஆ மார்க் டெஸ்ட் கொடுப்பீங்க. frequent மார்க் டெஸ்ட்டில் ட்ரை கரெக்டிங் யுவர் எரர் நோட்ஸ் கண்டிப்பாக மெயின்டைன் பண்ணணும். இட்ஸ் லைக் பேஸ் லெவல் ஆயிடுச்சு, ஓகே? இட்ஸ் லைக் தி நெசசரி ஸ்டஃப். இது இல்லைனா தென் your preparation is incomplete அந்த மாதிரி சொல்லலாம். பிகாஸ் வாட் எவர் நீ மிஸ்டேக் பண்ணுறனா அதை கரெக்ட் பண்ணுறது should be a part of your entire preparation. If it isn't, so yeah, it's incomplete. That's how we retain, okay? So வேற யாருக்காவது doubts இருக்கா? Ask me anything. Chapter is simple. So no one has any other doubts, okay? Nice. So everyone's preparation is paka. Ask me anything, but by the way, but see, when you organic chemistry, yeah, I have it here as well. Organic chemistry irka. I have inorganic chemistry. Inorganic chemistry, what I did now, I solid, I'll come to you, Safura, one sec. Inorganic chemistry, see, I have an example here. Say 13th group. 13th group ஓட atomic இல்ல ionization enthalpy. 13th group என்னது? Nitrogen, phosphorus, arsenic, antimony, bismuth. Okay, I still remember. So no, that's 3. Okay, that's not the 13th group. No, that's not 13th. I'm sorry. Okay, so 13th group வந்து your boron, aluminum, அந்த metal thing. Okay, ஸோ நான் இங்கே வெறும் இது மட்டும் வரைஞ்சிருக்கேன் கிராஃப். இட் கோஸ் லைக் இந்த மாதிரி. Okay, this is your ionization enthalpy, this is your atomic number வச்சுக்கோ. Okay, what the 13th group includes? Boron, aluminum, gallium, indium, thallium. Okay, boron, aluminum, gallium, indium, thallium. Okay, this is how I used to write. எனக்கு வந்து I don't remember the values because they don't ask values directா. They'll have questions where they'll in the மாதிரி relative ionization enthalpies or relative atomic radii இருக்கட்டும், relative melting point, boiling point, அதை பேஸ் பண்ணி தான் questions are asked. Okay, so இந்த மாதிரி I used to do. Now to organic chemistry, what I did was study NCERT. Whenever I seem to forget something in the reaction, in the name, say Gatterman-Koch reaction, I don't remember what it is. I'll go study the organic chemistry entire chapter again because it's super simple. You just have to look at the reactions and anganga reaction you would have to find what are the intermediates which it's forming. Okay, what are the catalysts used. Okay, what kind of reaction it is. அதை பார்த்தாலே it will be sufficient because yeah, that's what organic chemistry is all about. Whatever it's written, அது வந்து reaction they would have represented as well in most places. So my opinion will be what I did was studying NCERT again and again organic chemistry because yeah, I didn't know what else to do, but it worked because inorganic chemistry இந்த மாதிரி I can remember. Organic chemistry பார்க்க தான் all those images were in my mind because சின்ன change, temperature change பண்ணி கொடுக்கலாம் reactionsல. They would change the catalyst இருக்கலாம். Okay, so whatever questions they come up with, you must be ready to answer it. ஆனால் அந்த since the entire NEET organic chemistry is based on NCERT, if you remember all the reactions from your book, from your textbook, அதில் கொஞ்சம் மாடிஃபை பண்ணாலே உங்களுக்கே தெரிஞ்சிடும். பார்க்க இந்த மாதிரி டெம்பரேச்சர் சேஞ்ச் பண்ணியிருக்காங்க, இந்த மாதிரி இங்கே வந்து தி சேஞ்ச் திஸ் வேல்யூ அந்த வேல்யூன்ட்டு, அண்ட் தென் யூ கேன் ரைட் இட் அக்கார்டிங்லி. ஓகே, ஆனால் என்னோட போர்டு எக்ஸாம் முடிஞ்சு தான் நீட் ப்ரிப்பேர் பண்ண போகிறேன். ஏப்ரல் ஸ்டடி பிளான் சொல்லுவீங்களா? ஃபார் தட் ஐ நீட் டு நோ யுவர் ப்ரிப்ரேஷன் லெவல். இப்போ எங்கே வரைக்கும் நீங்கள் படிச்சிருக்கீங்க, வாட் ஆல் இஸ் யுவர் வீக்னஸஸ், வாட் ஆல் யுவர் ஸ்ட்ரென்த்ஸ், எவ்ரி திங். அது இல்லாமல் I can't help. So how has your preparation been so far, Sabit? Basically, April month is your month of mock tests. Okay, if you have been preparing இப்போ Sabit it's different. Okay, but when people who have been preparing for an entire year, repeater இல்லைனா for freshers who have been preparing for 2 years, it's little cold here. So basically in the March you should have started, everyone starts their mock test writing. Okay, race against the clock 3 hours timing you have to solve 180 questions அது எப்படி டைம் மேனேஜ் பண்ணி ப்ரெஷரில் everyone solves. Okay, if you haven't started that தயவு செஞ்சு பண்ணுங்க. ப்ராக்டிக்கல் சிலபஸில் என்ன மாதிரி படிக்கணும் ஃப்ரெஷர்னா? ஹாய் அரவிந்த், ப்ராக்டிக்கல் சிலபஸ் என்ன மாதிரி படிக்கணும்? Even for physics, பேசிக்லி அவ்வளோ பெருசாக ஒன்றும் கேட்க மாட்டாங்க. எங்களுக்கு என்ன கேட்டாங்கன்னா, they had so much syllabus. ஓகே, நிறைய they added இந்த பாட்னியில் நிறைய ஃபேமிலிஸ் ஆட் பண்ணாங்க. experimental physics, usually it's from your chapter, whatever chapters you're studying. Okay, there are the moments இது பேலன்ஸ் பண்ணுறது, vernier caliper இருக்கட்டும், and then a few more which I will discuss obviously. You have calorimeter, அதெல்லாம் வந்து it's all in your textbook. Okay, so what you're supposed to do now, find out what all are mentioned. Okay, find out what all are mentioned. அது மென்ஷன் ஆனதை வந்து you go refer to the chapter and have a glance, because அது without preparing அதுக்கு தனியாகவே you will be able to answer all those questions. Okay, usually you have yeah, உங்களுக்கு வந்து you have pendulum thing, spring simple pendulum, t square, L graph, Young's modulus தெரியும், spring constant of a helical spring also will thought, screw gauge, vernier calipers done, refractive index of a glass slab using traveling microscope. இதெல்லாம் I will teach, because without that the chapter is incomplete. I will teach. And then you have focal length of concave and convex mirrors and lenses using parallax method. Everything these are added. Okay, don't worry, everything will be covered. So yeah, basically all those இதில் வந்து கொஞ்சம் எக்ஸ்ட்ராவாக இருக்கிறது வந்து you have parallax method வச்சு focal length கண்டுபிடிக்கிறது, and then specific resistance of wire using Ohm's law. It's all included. Yeah, you have few topics which people don't focus much on. அது வந்து இனிமேல் தான் வரும். You will have from optics இருக்குது, optics I'll teach properly. அந்த it's simple. Parallax method வச்சு finding focal length is super easy. So yeah, so whatever experimental physics topics are there, they're all covered in the chapters which you are studying already. So you don't have to put taniya preparation, but just know what it is. Okay, I'm a partial dropper bro. Completed bio sir for physics. My study. You have finished the syllabus. The doubt is there's still time to start with only 0 for physics and chemistry. At this point, you might feel like giving up. Please don't. See, you have one month and 3 weeks. Structure your plan in such a way that you cover all the major topics of all chapters. So if say thermodynamics la indha unakku question kekkranga, say a graph question, which is like the most common question they ask. Graph la வந்து they'll ask work done, simple, and the work done question you'll be able to solve. If motion is straight line na, you have 3 equations of motion, அதை எப்படி solve பண்ணி you must know. Okay, formula and some application. You can't solve so many questions. Okay, that's impossible. because for proper understanding and all people use of 200 250 questions in ஒரு சாப்டர்ல பட் அது முடியலனா பரவாயில்ல. What was I saying? Okay. முடியலனா பரவாயில்ல பட் still try to have நிறைய formulas and application simple. Okay. It's கொஞ்சம் difficult தான் because when you don't know anything to start only it needs some courage. இப்போ but yeah, I think you will get it. Okay, don't worry. Great explanation by young and dynamic Medico. Thank you so much. Okay, class ஆரம்பிக்கலாமா? Class ஆரம்பிக்கலாமா? Class thermodynamics. So no one responds. Okay, see the thing is this chapter is very tricky for some lot of people, okay, including me. I didn't understand the first time, okay, but later I realized இது understand பண்றதுக்கு I need some few fundamental concepts from my kinetic theory of gases. Okay, so I have kinetic theory of gases. I அதை கொஞ்சம் லைட் டச் பண்ணிட்டு I have come back to thermodynamics again. So yeah, I hope you will enjoy this class and have no doubts இதுக்கப்புறம் இந்த chapter because it's simple. Okay, I'll finish it off சீக்கிரமா. And for those who don't know me, I'm Rihan. Okay, the thumbnail might look different, but I'm Rihan from Madras Medical College, second year MBBS. Here to take physics on Saranified NEET Guru. இன்னைக்கு thermodynamics எடுக்க போகிறேன். This is our team, Vidamuyarchi 2.0. Usually the classes வந்து 6 p.m. every day 6 p.m. and Sunday you have afternoon class. And exception இன்னைக்கு ஒரு நாள், okay. And we have an app in Play Store. If you want, go check it out. அதில் வந்து you have mock test. You have mock tests, okay. So many mock tests இருக்கு. You have 15 full syllabus where you can analyze your mistakes only, where you can compare your ranks with the other people who have already attended the exam. And then you have over chapter you have so many questions. Chapter wise you have 45 questions over chapter. I took for physics, Stanley took for chemistry, Samir Bose took for chemistry, Saranified took for bio. அது ஒன்று. The second one is you have daily worksheets available in the app. MCQ worksheets will be available, and whatever notes I'm writing here today, it will be uploaded in the app along with the link of this video. So you have everything for you. If you want, go check it out. It's just 499. Okay. This is thermodynamics. To secure a seat in Tamil Nadu topped government college, 650 to 680 போதுமா? Yeah, it will be sufficient. But it's still, I can't, ஏன் என்னால் சொல்ல முடியும் I can't predict properly னா, see என்னோட செட்டில் when we don't need examination. எங்கள் இயருக்கு முன்னூற்றி இயர் வந்து those who got 660 665, yeah, 660 they were in Madras Medical College. Okay, and then in my set they were it became 690 700 to 700 அந்த மாதிரி அந்த ரேஞ்சில் நிறைய பேர் இருந்தாங்க. The ranks are same. Okay, state rankல you should get below 250, obviously top 250, and அதுக்கு மேலே போனாலும் if you have some reservation you can get it. So it depends on the rank தான். So rank if you had a good rank na you'll get. What if so many people got 680 in the next year lab? It's not possible. It happened in my set though. So I can't for completely சொல்ல முடியாது நான் ஷுவரா. But if the cutoff of this year continues na, it will be super sufficient. You can get a MMC with 580 only. Okay. 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 Thermal equilibrium. I hope everyone stays here online. இதுக்கப்புறம் try to stay online. It's very easy. Okay, this chapter. Now there is something called as thermal equilibrium. What do you mean by thermal equilibrium? Okay, tell me, what do you mean by thermal equilibrium? Everyone would say thermal equilibrium is nothing but constant temperature. Temperature same ஆ இருந்தா thermal equilibrium on the body. Okay, அது சொல்லலாம். Now say I have two bodies. Appo you can say that if two bodies are thermally in equilibrium when the temperature doesn't change with time. Okay. Pakka. Now say I have an isolated system. Ipo I have an isolated system completely out of contact from anything in the universe. Okay, or isolated system irukenta. So basically this is my system and it's super isolated from the rest of the universe. Okay, this is my or gas irukku. This is my system. This is insulated. Okay. Now when I have an isolated system in the mari, how do I represent its thermal equilibrium? Can I tell it's in thermal equilibrium? Tell me. I can say because see when I have an object chumma normal or say in the square la there are few air molecules. Okay, there are a lot of air molecules. Now and the air molecules, just imagine they are not enclosed within a boundary. They can move freely. Even though if I had my hands in the muddy, if I close my hands, if I have air here ulla, they will still be able to interact with the other air molecules, other particles through my hand. they will hit, energy gets transferred through my hand. Fine. When they can be compressed by externally. So when there is temperature heat supplied here, the energy transfer ஆகி உள்ள வரும் ஒன்று. Then when they press பண்ணும்போது within this boundary only there is increased pressure. Okay, so basically for a system to be in thermal equilibrium, its macroscopic properties are supposed to be constant. ஒரு ஆப்ஜெக்ட் ஒரு சிஸ்டம்க்கு வாட் ஆல் மேக்ரோஸ்கோபிக் ப்ராப்பர்ட்டிஸ் ஆர் we gonna find? Pressure, volume, temperature, number of moles. These are all the macroscopic properties we are going to find. So when I call something in thermal equilibrium, this is what I mean. All its macroscopic properties should be constant. Okay, this is for a single system. When I enclose something in the mari and I isolate it completely from the rest of the universe, you'll have no interaction. When there is no interaction with the rest of the universe, the pressure won't change, the volume won't change, the temperature won't change, the number of moles won't change. So can I call this system of mine to be in thermal equilibrium? Yeah. Okay, nice. Fine, paka. We all know in the equation irukinte PV equals to NRT. Pressure, volume, number of moles, temperature, and this is your gas constant. Okay, fine. Now இப்போ பாருங்க, இப்போ வந்து என்கிட்ட thank you madam. I would really appreciate you people to put thumbs up in the chat whenever you, if you have any doubts அப்படியே கேளுங்க. I'll try to explain it again, or you can just rewind it back. Okay, I want this live session to be like super interactive. Okay, normal class இருக்கிற மாதிரியே இருக்கணும்னு நான் எக்ஸ்பெக்ட் பண்ணுறேன். அதனால because if you take any other YouTube channel, I've seen YouTube channels நிறையா in my preparation அப்போ they don't repeat stuffs. When they teach it once, அது ஒரு வாட்டி நடத்தி விட்டுருவாங்க. Still, because since it's recorded, you can still go back and check it out. But I don't feel like doing it because there has to be some interaction so that this class can go well. Okay, done, paka. Say I have okay, இப்போ வந்து See, there are two containers, okay, which have a diathermic partition amongst them, and a completely insulated outer shell to prevent them from interacting with the rest of the universe. This is my adiabatic insulation, okay, partition. So this is my say system A, this is system B, okay. You know, either one they say this is a temperature T1, this is a temperature T2. I can call them to be in thermal equilibrium when, see, if T1 is greater than T2, let's go. Appo enna agum, heat energy passes from T, this one, it goes here, and finally ultimately they become the same temperature, right? This is your thermal equilibrium for two systems. This is single system, this is the basic definition, this is the thermal equilibrium for two systems, okay. Right. Now when two bodies are in contact, say இது வந்து ஒரு 50 degree Celsiusல இருக்கு, இது வந்து ஒரு 75 degree Celsiusல இருக்கு. இது வந்து when they are kept in contact, will heat transfer from இங்க இருந்து இங்க? கண்டிப்பா, வெரி ஆப்வியஸ். ஸோ இந்த மாதிரி ஆகும்போது ultimately they will get into the same temperature. Okay. Okay, Anna, thank you so much இதை சொல்லி கொடுத்ததுக்கு. But you might ask me something, what even is temperature? So temperature நமக்கு எல்லாம் தெரியும், but what even is temperature? From very basic level, because when you understand the basics of this chapter, பக்காவே இருக்கும். அப்படியே you will have concepts, அவ்வளோ conceptual clarity, it will be very really helpful. ஏன்னா இந்த சாப்டர்லேருந்து usually they won't come numericals, they can ask numericals actually. நான் வந்து வராதுன்னு சொல்ல, they usually don't ask questions, okay. Isothermal processல work done கேட்டாங்கன்னா முடிஞ்சு, you have to calculate. It can be very complicated, it can be very simple as well. Adiabatically கேட்கலாம் work done, okay. You should be gamma minus 1 to r into del t by 9 அதெல்லாம் போடணும், but they don't ask, they ask from basic concepts. That's what we're gonna clear, okay. I will discuss those questions as well, but don't worry. Now, what even is temperature? So no one has any doubts, thank you. I'll be using this inhaler apopo because I don't feel well. Please excuse me. And then yeah. So what even is temperature? So temperature basically is the capacity of an object, okay, to transfer its heat energy, okay. Heat nale it's energy now. So capacity of me to transfer my energy, my heat to surrounding or other bodies is my temperature, okay. Consider temperature to be like a concentration, Mari, okay. When you have, say you have two containers, okay, 1 liter container ஒன்று இருக்கு, 10 ml container ஒன்று இருக்கு, okay. For them to have the same saturation of say ஒரு tank juice mix. Okay, we have to put it in for them to taste exact same cause saturation or fruitiness or everything. I should add more tang powder to my 1 liter can. Then I'm going to add that in my 10 ml thing. Okay, 10 ml can, but still I'm telling you. The reason being, only then I'll have proper taste. I won't feel any difference between this and this one. Now consider the volume to be mass of substance. Okay, so 10 grams and 1 kilogram, and the amount of tank that I put is my energy. So to have the exact same temperature, I have to use more energy for a heavier object than that of a lighter object. Okay, இது புரிஞ்சிருக்கும் நான் நம்புறேன். If you didn't get it also, I'll teach you the exact same concept in thermal properties of matter. Don't worry. Okay, if you want to have கொஞ்சம் recap பண்ணணும், கொஞ்சம் rewind பண்ணி you have look into it. Okay, so yeah, basically இவ்வளவுதான். Okay, and then zeroth law of thermodynamics. Zeroth law of thermodynamics. I'll give you the feel of what this actually means. See, first law of thermodynamics வந்துருச்சு. Yeah. Second law of thermodynamics also came out. But then you found something else which is super fundamental than the first law. அதனால அது zeroth law பேரிச்சிட்டாங்க. Don't ask me why they named this law. அவ்வளவுதான், அதான் history. Now, when you have say you have 3 bodies, okay? Paka, I have 3 bodies. A, B, and C. 3 bodies. Now say my A body is in thermal equilibrium with the B. Okay, and A is also in thermal equilibrium with C. This is reversible reaction, okay, but still okay. This is thermal equilibrium with C. Then zeroth law states that B and C are in thermal equilibrium. This is your thermodynamics or zeroth law. Okay, இது வரைக்கும் simple. இதுக்கப்புறம் I want you to understand the concept of internal energy. It's beautiful. Okay, the entire chapter on the if you understand this thing na, you'll understand like 90% of this chapter. It's all done. அதுக்கப்புறம் just the derivation formulas and all. Put your pens down. Okay, if you have anything in your hand, keep your phones or tab or just listen to me for 2 minutes. Okay, imagine you're able to see air molecules. Okay, you're able to see air molecules. They're large enough to actually have to actually reflect light. Okay, fine. When you observe them, you see them, when you see them, you find there are interactions between molecules. Okay, fine. And these molecules are randomly moving. Okay, when mechanical properties of solids, I told you there is a lowest potential energy state where the uh, molecules or atoms find equilibrium at. Okay, okay, fine. So on the equilibrium point, they stay, and but since they are moving, they'll have some potential energy and some kinetic energy. Why is this potential energy? Because molecular interactive force. Because in the electron, under electron repel panno, obviously, and then the nucleus will attract the other. Fine. So there is potential energy. I figured it out why potential energy is there. And then since when my பார்க்கும்போது obviously air is not static. It keeps on moving. Kinetic energy. Fine. So இப்போ ஒரு சிஸ்டமோட internal energy நான் பார்க்குறேன்னா, it includes both potential energy plus kinetic energy. This is because of the interactive forces மட்டும்தான். This is because of movement. Clear? You understand? Do you understand why there is a concept of internal energy and what all it includes? Paka? Now tell me, இப்போ வந்து நீ சும்மா பார்க்குற the gas particles are moving, I mean air molecules are moving. Yes, they're moving. They're having some kinetic energy. So I am adding this thing called as K. Yeah. I don't see reply, guys. Come on, reply something. Okay, no more. Thank you so much. So இப்போ அதே வந்து say I'm having a system. I'm having a system which I'm moving. Okay, thank you, Mano. Only Mano said he understood. Okay, when I'm having a system which I'm moving. So when I'm moving stuff, it'll have some velocity. Yeah? Will that velocity be accounted as its internal energy? Tell me. So okay. Yeah. So when I'm having an object moving, எப்படி I'm having gas உள்ள. Okay, moving at the velocity, say its mass is m, moving the velocity of v, it'll have a kinetic energy of half mv square. Okay, right. This does come under internal energy. I get add up because of its kinetic energy. Basically, our particles will be moving. When you push it more even further, the velocity of individual movement of particles will increase. So obviously, it will increase. Fine. Okay. Now let's take what an ideal gas is. Basically, physics lab in your 11th and 12th, when you don't know, when you have too many factors to have an effect in your results. Okay, this is so funny. You have ideal liquid fluid. Okay, for and you have ideal gas. Whenever you have நிறைய variables, we consider something to be so ideal, okay, that it doesn't have all those. இப்போ பார்த்தீங்கன்னா you have potential energy, due to interaction. an ideal gas is something that doesn't have any interaction. Okay, so when it doesn't have any interaction between its own molecules, it won't have any attractive, any repulsive forces. It's basically zero potential energy molecule. I mean, basically it has zero potential energy. So when it has zero potential energy, other entire internal energy is based on it is dependent upon the kinetic energy of individual particles, right? Say there are some particles particles. Okay, say these particles were interacting. Okay, interaction only will have potential energy, and this particle is, say, it's moving in some velocity p. It's moving in some velocity p. Okay, இது kinetic energy தரும். But in an ideal gas, இந்த interaction இருக்கு இல்லையா, absent or no interaction. When you have no interaction, okay, when you have no interaction, அப்போ potential energy becomes zero. So your internal energy is equal to kinetic energy. This is for only your ideal gases. And in the chapter full we'll be discussing about ideal gases now. Paka clear? Understood, Mano? Thank you. Okay. So in the case la total energy is equal to internal energy is equal to kinetic energy. Paka question. Please chat box reply பண்ணுங்க. It's super low energy டிக்கா இருக்கு இங்க. I don't know what I meant by that. ஆனா obviously எனர்ஜி இல்ல, எனக்கும் எனர்ஜி இல்ல, chat boxலயும் எனர்ஜி இல்ல. தயவு செஞ்சு you do reply something, okay, if you have anything now to say. Okay. Degree of freedom. Okay, the exact same thing. Internal energy பண்ண சொன்ன மாதிரியே for 2 minutes close your eyes or keep your pens aside, notes aside, and understand this concept. It's very 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 beautiful. Okay, very beautiful. Now say I have a molecule, a gas molecule. Nallave. Of all the variations I could have a monatomic, single atomic. I could have a diatomic. I could have a triatomic. All these are called as a polyatomic, okay, which can either be straight or bent. Same. Okay. This is your thing. When same இப்போ வந்து particles I told you that internal energy zero internal energy is dependent on kinetic energy entirely. So kinetic energy என்னென்ன வேஸ்லலாம் இருக்கலாம் ஓகே அது வந்து it's showed by your degrees of freedom. Freedom azadi basically how free you are, okay, how free you are. Suppose you could move, how free you'll be able to move now, that's your degree of freedom. Let's say I have a monatomic gas, okay. The monatomic gas it can have two types of kinetic energy. I have discussed this already. You can have a translational and you can have a rotational. Okay. Okay. See, in the molecule வந்து it can go இந்த மாதிரி x directionல போலாம், y directionல போலாம், z directionல போலாம். All three ways it can move. I told you like this one, it's not included. I'll tell you why. My molecule will be able to move in the மாதிரி vibrate along z axis, vibrate along y axis, vibrate along x axis. Okay. And for rotation, same. But rotation, if you want to consider now, it will be around over axis மட்டும்தான். But let me tell you how this works. When you say this is my monatomic gas, okay. இதுல வந்து if it rotates around its own axis, say it's a solid sphere, okay, solid sphere it's 2/5 mr square. Moment of inertia into omega square into 1/2 is your rotational kinetic energy. Omega square, if you see this r this is its radius. This r is the atomic radius of the atom. Okay, so when it's the atomic radius of the atom, it's more small. When it becomes r square, it's even smaller. So this entire term is negligible. So you have three ways how in which my object, my monatomic gas can have kinetic energy. 3 waysla, and it has 0 ways of having potential energy of rotational kinetic energy. See, the rotational kinetic energy also requires energy, okay va? If energy rotates also it needs energy, appo it'll have rotation. Again, since it's 11th and 12th physics, we just ignore everything. It still there is energy, but it's so insignificant we just don't consider it. So rotational kinetic energy is basically 0 because it's negligible, okay, compared to the other ones. இது புரிஞ்சா? DK dreams, you'll be able to crack it, don't worry, okay. Okay, it came here. You'll be able to crack it. Okay, fine. Okay, monatomic. Next, let's get into, so the degree of freedom of a monatomic gas is 3. Degree of freedom is 3. Say diatomic, same concept. Translation, you'll have 3. Kandipa, it'll move in the mari, mada, kira. Okay, 3 directions. And then you have rotational. Now the rotational line, there's a difference between monatomic and diatomic. Okay, diatomic la, you can have rotation ipdi along the axis and இங்கேயும் பண்ணலாம் rotation. ரெண்டு விதத்துல. Okay. So when you consider this one, same, r square becomes insignificant. Thereby, rotational kinetic energy is neglected. But this one, in the அது வந்து இந்த along this axis, but in the axis la rotational kinetic energy வந்து நம்ம accept பண்ணிக்கிறோம் because there is radius, sufficient radius. If you see the distance is greater than that of the atomic radii. Okay, fine. Now the rotation can take place in two different axes. One is my not along the axis of those two atoms, but in the axis leo it can rotate. It can rotate ipdi and it can rotate ipdi vertical. Ipdi rotate ana and it can rotate ipdi. Okay, so my degrees of freedom is translational 3, rotational 2, total 5 degrees of freedom. So basically, again I'm telling you, degrees of freedom is nothing but the ways at which a molecule can possess kinetic energy. Okay, so it can possess in the level in the 8 times, I mean 5 different ways of kinetic energy வச்சிருக்கலாம். Okay, how free the molecule is basically. So now polyatomic. Now the polyatomic வந்து say I have carbon dioxide. Carbon dioxide is a linear molecule. So in the linear molecule the same thing applies. I have 3 translational motion and then 2 rotational, because along the axis it won't have any moment of inertia. Okay, I mean negligible. Okay, அதே வந்து if you take sulfur dioxide, இங்க பாத்தீங்கன்னா you can have 3 ways of translational motion. You can have 3 translational motion. And then I can have 3 vibratory motion, 3 rotational motion. In the axis rotation, in the axis rotation, and in the axis rotation. Basically in all 3 axes there can be rotation, because when you see, even though ரெண்டு ஆக்சிஜன்ல போனாலும் you have sulfur அந்த பக்கம், so அதோட there is moment of inertia. Okay, I'll write definition again. Number of independent number of independent terms to express kinetic energy. Okay, understand, this is very beautiful thing in the we're deriving stuff. Okay, clear? Clear na? Send me a thumbs up in chat. Okay, no one's replying. Thank you. Oh, thank you, Mano. Okay, I'm done. This is what my polyatomic is. So I'll give a question which came in 1993 AIPMT. Simple, very என்ன கேட்டாங்கன்னா the degrees of freedom of a triatomic gas. Okay, triatomic gas oda degrees of freedom usually you consider it as non-linear. So as triatomic, the degrees of freedom is 3 translational and 3 rotational. So degrees of freedom and the if it's linear na 5, non-linear na 6. Okay, and there's one thing you must consider எல்லாத்துலயும். I'll add a note here. அதாவது whenever it's given high temperature, add +2 modes for vibration. Okay, done. Pakka. This ideal gas, monatomic, diatomic, polyatomic. Okay, there's this law of equipartition. Okay, which states that for the average kinetic energy, okay, the average kinetic energy associated with the average kinetic energy associated with any molecule. Okay, with a molecule of gas is given by half into K into T, where K is universal gas constant by moles. This universal gas constant which is represented by R, it's for 1 mole of substance. Okay, divided by Avogadro's number, you'll get K. This is for one single molecule. Fine. Okay, this is what they have found, and if you see nalla clear, it depends upon temperature. Okay, so internal energy is dependent on temperature only. That's why this is not included. When you move something, when you move a system, it gains some kinetic energy, but it's not included because internal energy depends upon only temperature. Okay, don't ask me why how we got into this conclusion of half kT. Okay, Now, since for every molecule or every degree of freedom ko I'm having 1 by 2 kT. Okay, every molecule, this is every degree of freedom I'm having one means 1 by 2 ஒரே ஒரு degree of freedom I'm having 1 by 2 k into t. This is my for every degree of freedom. அப்போ ஒரு மாலிக்யூலுக்கு through all its degrees of freedom, what will be the average kinetic energy? It's nothing but degree of f by 2 into kT. This f by 2 into kT தான் வந்து என்னோட total kinetic energy or total internal energy of one molecule. Okay, when you consider 1 mole of substance, it will be f by 2 into r into t. This is the internal energy u of 1 mole. Say if I have n moles, it will be equal to n into f by 2 in r into t for n moles. This is my law of equipartition. Basic. So and I have to tell you one thing. This entire chapter la, wherever you find temperature, convert it into Kelvin. Okay, SI unit is Kelvin now. Right, convert it into Kelvin. We use Celsius in India la. People use Fahrenheit in some countries, but Kelvin the one we are supposed to use for calculations purposes. Okay. Okay, so ஏதோ பிரச்சனை. Okay. Okay, done. Paka. There is something called wrong with the thing. Okay. For the streaming, it's not made. Is my video smooth? Guys, tell me in the comments சீக்கிரமா கொஞ்சம் சீக்கிரமா கொஞ்சம் ஒரு few minutes back did my no data. Check. Okay, பக்காவா இருக்குன்னு நினைக்கிறேன். இப்போ guys, is my video பக்கா இப்போ? Oh, I did get stuck for some while. Okay, fine. Now it's paka. Okay. Now we found about internal energy na enna internal energy foundation கொஞ்சம் detailed we had base built up இப்போ வரைக்கும். Now we are at the state where we will able to understand that molecules or individual kinetic energy only for an ideal gas gets included in its internal energy and not everything else. So now see, okay, just for listen. Say I'm having a system with some molecules of air and I'm heating it up. When I heat it, before that, let's first internal energy or equation I எழுதுறேன் first, which is nothing but n is the number of moles, F by 2 is the degrees of freedom divided by 2 into R into T. This is my internal energy order formula. This is how I'm going to find it. Why I'm calling this, why இப்படி சொல்றேன்னா, this is from, I got it from my law of equipartition of energy, and the law of equipartition of energy is for all the kinetic energies. Okay, so this is my formula. Okay, Paka, okay, I don't see anyone giving thumbs up in chat. Please do. Okay, fine. So yeah, so basically this is what it is. Now if I want to find the change in internal energy change அது. Okay, அப்போ தான் என்னோட kinetic energies of my individual molecules is changing. It changes because the only variable factor in this, okay, the only variable factor is my temperature. So when I consider change in internal energy, the எல்லாமே சேமாக இருக்கும், n by 2 f by 2 and n into f by 2 into r del t. So with we note it again, note internal energy is dependent only on temperature. Okay, குட்டி எழுதிடுறேன். Okay, okay. Now one question, one சின்ன question. Say I have nitrogen N2. What are 4 moles at 27 degrees Celsius? What will be the internal energy of this thing? Internal energy. I have to find. What is the formula? N by 2 into FRT. Okay. What is N? Number of moles, which is 4. Okay. F is degrees of freedom for a diatomic molecule, 3 translational, 2 rotational, so it's 5. Divided by 2 into R, with my universal gas constant, into temperature. T is nothing but, I should take it in kelvins. So 273 plus 27, 300. So it's R into 3000. Okay. Guys, I am extremely sorry on the behalf of whatever is happening, bro. Suddenly the YouTube says that I'm not, that there is no, what did he say properly here? I'll tell you. Stream health. We are not currently receiving any data from this stream. I'll check it out, okay? Up now it's stream is healthy. Now it's healthy. There may be little lag up. It's probably a Wi-Fi thing. I don't know. So yeah. So this is our chinna concept. Okay. In the cover we have something called a specific heat. Okay. Um. See. I'll check what this issue is and I'll be back. Okay, in 5 minutes. Okay. Yeah. I need some time. I'll take. Let's take a break because I don't know what's happening with this thing. I'll check it out. Let's take a break for now. It's 43. 5 o'clock start now. Class resumes at 5 p.m. Okay. Things which I have to focus on next now. Specific heat capacities, CVCP, and then work done in laws of thermodynamics and process adiabatic, isothermic, isothermal, uh, adiabatic, isothermal, isobaric, isochoric. Okay, all four process pakka discuss பண்ணிட்டு and I have so many questions where I will solve. I've selected few. I will solve that. அதுக்கப்புறம் we'll finish the class. It's easy, simple chapter because the questions are super direct இப்போலாம். So yeah, okay. So okay, see you. Stream health. All right. Hi guys. Okay, hi guys. Oh, now the YouTube stream is healthy. Okay. We have Brook P4J. Yeah. He's saying that he got 685 marks in the part test. Okay. Chemistry 5 lessons, physics 5 lessons, and then bio 8 lessons. He's asked. Okay. Okay. இப்பதான் வந்திருக்கேன். You've sent the same message three times. Can I do this consistently and get a good college, sir? Me. Um, you're gonna write this exam on NEET 2026 or 2027. Which one? If it were 2027, you're already rocking, okay? 2026, try to stay consistent. If it were 2027. 2026 also, you're in the very பக்காவான state இப்போ. If you're able to score 685 now, you know how it feels. You know how to manage time while scoring அவ்வளோ. You know how to, yeah, time management it's more important. You know how it feels. So you would obviously want to feel the same way again. So you will definitely score well in the other tests as well. Yeah, 2026 self-financing வேணும்னா at least self-financing. See, you got 685 in a part test, okay? Grand test போகும்போது your marks will குறையும், கண்டிப்பா குறையும், okay? But still you'll be able to get it if you get this exact same range. Like if you get above 650 in all the part tests and grand test நல்லா score பண்ணினா, why self-financing? You can get good government colleges as only. But if you want self-financing, it's still you'll get it, okay? If you get the exact same marks போக போக. Okay, don't worry. That's really good. 685 in part test, yeah. All right, bachcho. Okay, so the stream keeps crashing for some reason. Clear, huh? Specific heat ஆரம்பிக்கலாம். I'll give you one question. The question முடிச்சுட்டு will start specific heat. So you have one gram. அதோட temperature from T1 லேருந்து I'm raising it to T2. Okay. இப்போ T1 to T2 rise on this thing, I have to find out the change in internal energy. Okay. Basically ஒன்றும் இல்லை. So it's 1/2 into F into N into R into T del T. Degrees of freedom for helium, it's a diatomic illa monatomic gas, so it's 3. N is number of moles. Number of moles inga vande 1/4, so it's n of Avogadro divided by 4 into because if I'm taking molecules inga, so if I'm having Avogadro number of molecules by 4 into k, they'll get the T2 minus T1. This is the change in internal energy. Fine. It's very basic stuff. Like everyone knows this. We'll finish this class. Okay, don't worry. Because you need some break before starting the next class as well. So I understand. So specific heat. Thermal properties of matter. The specific heat. Okay. This is a formula. Q is equal to MC del T. Okay. In definition words, it's nothing but amount of heat required to of heat required to increase temperature of 1 gram of substance to 1 degree Celsius. Sorry, by 1 degree Celsius. Okay. 1 gram of substance 1 degree Celsius நான் increase பண்ணனும்னா increasing its temperature by 1 degree Celsius na, the amount of energy required is my specific heat. Okay, do you get this? Okay, fine. So you can write it as my specific heat is equal to Q del Q divided by M del T. For 1 gram of substance, the amount of heat is my specific heat. Okay, this is your specific heat. Now you have something called as molar specific heat. Where it's for Avogadro number of molecules. Okay, where it's for in terms of moles. For 1 mole of substance or 1 Avogadro number of molecules இருக்கிற substance எவ்வளோ எனர்ஜி தேவைப்படுமோ, that's my molar specific heat. Okay, done, paka. So இங்க வந்து I used mass. This is mass. This is my temperature. இங்க வந்து I'm using Q is equal to NC del D, where N is the number of moles. Paka. Now we have two simple concepts, CV and CB. CV is my specific heat at constant volume. ஓகேவா, இது எல்லாருக்குமே தெரியும். Specific heat at constant volume. Yeah. Okay. இது வந்து in constant volumeல it's constant pressureல there is a difference. Okay, fine. Okay, angle right. CPCV. Okay, I think pakka work ante. Let's finish this. Okay, specific heat, CP and CV relation in terms of F/2, in terms of degrees of freedom. பார்த்தோம்னா my internal energy U is equal to NCV del T. NCV del T is also equal to N into F/2 RT. So my CV is equal to F by 2 into R. And we know for a fact that CP minus CV is equal to R. Apona my CP is equal to F by 2 plus yeah, this is my CP, this is F. Okay. Fine, paka. Easy. Done. Okay. This is basic stuff. Okay, the CP relation. Next, work. There is this concept in this chapter, okay? கொஞ்சம் complicated இல்லை understanding வந்து you'll forget because chemistry it's in one way, physics is in a different way, but they're both technically right. I'll tell you what. Yeah, இப்போ ஸ்ட்ரீம் நல்லா தான் இருக்குன்னு நினைக்கிறேன். Okay, so work in thermodynamics done work done is usually nothing but P del V. Okay, done. அதே இப்போ ப்ரெஷர் வால்யூம் கிராஃப் எடுத்துட்டோம்னா this is P, this is V. See, this is my process. இதான் இப்போ தான் மூவ் ஆச்சுன்னா என்னோட சிஸ்டம் ப்ரெஷர் ஃப்ரம் P1 to P2, இதெல்லாம் வால்யூம் ஃப்ரம் V1 to V2. இதோட ஏரியா இருக்கு இல்லையா, this area எதுவுமே ஓட்டு. ஓகே, clear பக்கா? Yeah, I think it's clear. நல்லா தெரியுது நினைக்கிறேன். இப்போது ஸ்ட்ரீம் stream is healthier than அடுத்து and preview is also good. Okay, fine. Science of work பார்த்தீங்கன்னா work done இருக்கு இல்லையா, the work is being done. It will be positive or negative because work is a path function, not state function. Internal energy இப்போ எடுத்துட்டீங்கன்னா it is a path function. I mean, internal energy is a state function, but work is a path function. A path function is state function. Law we would have seen it in work power energy. Path function, the amount of work done depends upon the path it takes. Okay, அதே வந்து state function is totally அப்படியே opposite. State function depends on the state of the thing. Okay, initial state to final state based பண்ணி you have, if you take gravitational potential energy, the entire thing is based on only 2 points. Okay, when you have potential energy 1 point, potential energy at other point, அந்த 2 pointsக்குள்ள நீ எப்படி வேணா மூவ் ஆயிருக்கலாம், but your change in potential energy will be the same. Fine, அந்த மாதிரி தான் our internal energy. It's a conservative thing. Okay, that's why it doesn't depend upon path, rather state. Right, but work done by a system or on the system can be positive and negative. Okay, that's the thing. When I have a piston and I have a cylinder, this is where they do all the thermodynamics is entirely dealt. you have this thing. Okay, nice. So see, இதுக்குள்ள வந்து there are molecules here. See, when I push this piston உள்ள என்ன ஆகும்? Say it was initially இங்க. When I pushed it, it went இவ்வளோ தூரம் உள்ள. Okay, there is a change in volume which is a negative change. In physics we consider this thing so that the work done by external force or the work done is taken as negative. Okay, அதே வந்து when this gas expands on its own without any external force, it expands, saying it has some del v which is a positive change in volume கம்மியா இருந்தா அதிகமாகுது. So when there is an increase in volume, okay, when there's an increase in volume, so thereby I can call the work positive. Okay, now chemistry, it deals up with the internal energy. See, உள்ள வந்து these molecules, they have நல்ல energy they have. Okay, okay, done. Paka, this is a sign of work usually. And then we have something called as gamma, which is nothing but Cp divided by Cv, and then nothing but F by 2 plus F by 2, F plus 2 by F by 2. Gamma, ratio of between Cp and Cv, gamma. Okay, done. Okay, work done on the. Okay, I'll summarize till now whatever happened. We found out the degrees of freedom, okay, of the gases are 3, 5 and 6. Okay, okay, stream is good now, good. Okay, internal energy is equal to kinetic energy of molecules, which is equal to N F by 2 into R into T into N. Okay, change in internal energy is equal to del T. Okay, Cv is equal to Cv, Cp is equal to F by 2 plus 1 to R. Cp minus Cv is equal to R. Cp by Cv is equal to gamma, which is equal to 1 plus 2 divided by F. This is basic stuff. இது வரைக்கும் நடந்துச்சு. ஓகே, இன்னும் கொஞ்சம் நேரம் போனால் ஐ கேன் சால்வ் யூ கொஞ்சம் நல்ல கொஷின்ஸ். இன்னும் கொஞ்சம் if I okay. Units. Work done on a unit is nothing but joule. Sometimes it's in calories as well, where 1 calorie is equal to 4.2 joules. இருக்கலாம். ஓகே, ஸோ எல்லாமே இருக்கலாம். Okay. Let's see work done. I'll give you an example. I don't know. I'm trying so much, so something in all. It's not working, guys. எனக்கு என்னோட ஸ்ட்ரீமே தெரிய மாட்டேது. I don't know if you can even hear me. It seems pointless to teach இப்போ. It doesn't even, it shows no data. Okay, I'll try something, because we have to finish thermodynamics pakka clear. It should work. Yeah, it's working. Stream health is excellent. Thank you. One question: when you have a gas whose volume changes 0.25 meter cube at pressure 10 power 3 pressure la இவ்வளோ வந்து so I'm supposed to find what the work done. It's nothing but P del V. P del V. So P into pressure is 10 power 3 meter cube la 2.25 into 10 power minus 2 வச்சுக்கலாம். So it's 250 joules. Okay, now sometimes they would ask in a different unit, say ergs is nothing but 10 power 7 joules, so it will be nothing but 250 into 10 power 7 ergs. Okay, this is a question I wanted to solve. Now, work done by a PV curve is, say the pressure of was initially inga, the final thing point system out of present volume says whether I went in this path. Okay, my the area under what the curve, okay, the curve area தான் வந்து என்னோட okay, this is my work done. Okay, I'm telling you again, work is path dependent. அதாவது say if I have a graph இந்த மாதிரி, okay, these are the three parts. Okay, since the initial state, initial p1 v1 state lende final p2 v2 state, okay, initial state final state they are same. Since they are same, the change in internal energy is same, but work done is different. The work done என்னன்னு பார்ப்போம். இப்போ நீங்கள் இந்த கர்வ் எடுத்துக்கிட்டிங்கன்னா, இந்த கர்வ் the green one curve எடுத்துக்கிட்டிங்கன்னா அதோட ஒர்க் டன் வந்து this will be its work done. The area. So basically this will be its area. Okay. But if you take this curve, blue curve, you'll have this added. This thing added. You'll have more work done for blue curve. Otherwise, if you take the yellow one, it will include this. It will include. So if you take yellow, it will include yellow plus blue plus green. Adhe blue at the, it will include blue plus green. Adhe green at the, it will include just green. So basically this is your work done. See, for individual path, the work done is different. Yeah, I don't know what is wrong with this stream. Okay, so yeah, this is my work as path dependent. But whereas U is state dependent, அதாவது initial and final states. For a particular pressure and particular volume, you'll have some temperature, right? Because they are related. PV equals to nRT, and for particular pressure and volume, you'll have a particular temperature. So when you finally reach a particular temperature and pressure and volume, you'll have a particular temperature. And we for a fact know that internal energy is equal to F by 2 into N into F by 2 into RT. Okay, so my internal energy completely depends upon temperature. Thereby I can say that this is equal to constant. I mean, for my U is state dependent. Okay, paka. Okay, one example. Okay, so this is my pressure volume graph ஒன்று இதில் வந்து the process is circle. Okay, okay. So if you see this radius இருக்கு இல்லையா, radius is nothing but P naught. Volume is nothing but V naught. Average volume. Yeah, this is இதுக்கு it's V naught and இதுக்கு it's P naught. Radius of one axis radius is P naught, other axis radius is V naught. So since the area of the circle is, so work done கண்டுபிடிக்கணும். Okay, basically area of the circle is pi r square, but r square we can't use because there are two different radiuses, so we just multiply those radiuses along with amongst them. So it will be pi into P naught into V naught, simple, which will be 22/7 into P naught into V naught. This you must know. Why are we doing this? Because there are no Or stream is healthy. Super. There are no, this radiuses are not same. Where over axis the radius varies. So we have to take రెండుమే ఇంగా. Okay, I hope it's clear. Okay, Paka. One more question. Okay, say you have PV graph again. Usually this is what they ask you more எப்போவுமே a PV graph. Okay, this is the path the system had taken. This is P1, this is V1, this is P2, this is V2. Okay, now I have to find இதோட work done. It's simple. It's nothing but the area under the curve. So what I do in the line and you join point. Okay, okay, this will be my this is I don't values will never pull. Okay, so this is my process. Okay, from here to here. Then on a process the process ke this P1 V1 P2 V2 இதை பார்க்கணும் எப்படின்ட்டு. So basically how you have to find the area under the graph. Area is nothing but you have this area which is a square or a rectangle அந்த மாதிரி. And then you have this area, male area. Okay, so you have two areas. These two areas are to be calculated. Okay, okay. Change in energy பார்த்தாச்சு. Okay, let's see the first law of thermodynamics. இது வரைக்கும் whatever I taught you clear up. Let me know in the comments. Come on guys. till now. Okay. NEET level whatever what's required I'll teach you. In the inga. Okay. It's nothing but based on conservation of energy. Basically simple. Okay. See, I have a system. Okay. In the system lab, I'm adding some energy, heat. Okay. This heat, what will happen? It will change its internal energy, one, and it will do some work. Okay. Some work is done, and there's a change in internal energy. This is what my first law of thermodynamics is. Thermodynamics, yeah. Dynamics, yeah. I must MICS. Yeah, M. Okay. So see, basically you have heat supplied. This supply panna heat is equal to change in internal energy plus some work done. அவ்வளோதான். இவ்வளோதான் என்னோட. This is some internal energy change. There's some work done. Clear? Okay. Okay now. ஒரு நல்ல question. இதுக்கப்புறம் I need more pages. I'll give you a good understanding of first law of thermodynamics. அதுக்கப்புறம் processes are simple. Okay. Processes are simple. Okay. Internal energy of a system. Okay. Say I have absorbed 2 kilocalories of heat and my system has done 500 joules of work. What will be the change in internal energy? See guys, there will be questions in NEET examination if they want to step it a little bit higher. Okay, கொஞ்சம் difficult பண்ணோம்னா this internal energy thing la, we all know that this internal energy is dependent upon, I mean this internal energy தான் வந்து temperature determine பண்ணும். Okay, so basically when you have temperature and internal energy here, they will connect this chapter inga with thermal properties of matter. So with the internal energies, they'll give a process and they'll tell you this work done heat supply is this much, and they'll ask you how much is the change in internal energy. Okay, and the internal energy change மூலமா you use specific heat of that particular substance, and then you're supposed to find the change in temperature. Okay, it's simple, but still if you want a little bit twist the questions na இந்த மாதிரி கேட்கலாம். Yeah, so 500 joules of work. So 2 kilocalories, 1 kilocalorie is 4.2 joules, so this is 8400 joules. We all know Q is equal to del W plus del U. Work done by the system. So technically it's positive. So Q is 8.4K, 8,400 equals to 500 plus U del W plus del U is 2. Oh, that's all you're supposed to find. So change in internal energy is equal to 7,900 joules. Simple basic question. Hmm. Hmm. In a closed in a closed loop, change in internal energy is 0. Why is it 0? If you may ask. Yeah, see, internal energy change is pretty straight, கொஞ்சம் complicated, because if you see, I mean கொஞ்சம் simple தான். When you take internal energy, it depends upon temperature, and when temperature வந்து ஒரு particular pressure and particular volume, you'll have a single temperature, right? That too, it's subjective. Okay, so but when you have or a particular, when you move from one state, go to a lot of states, and then come back to a same pressure and volume, you'll have the same temperature. So when you have the same temperature, your change in internal energy is 0. This is a concept you want you to know. If Q, second law of thermodynamics is based on entropy. Okay, I don't think it's necessary. It will be discussed in chemistry. I just give you an idea. Second law, I'll give you an idea and then I'll come back to first law. Okay, I think video is pakka. Second law of thermodynamics is it's supposed to be in the last. Okay, I'll just give you the basic idea. In detail you learn in chemistry. It's basically total entropy always increases for spontaneous irreversible processes. Okay, video. Okay, I feel like it's buffering அப்பப்போ stream is நல்லா தான் இருக்கா இங்கே? Oh, it shows buffering for me. Okay, all right, this is what your second law of thermodynamics, and அதுக்கு பெருசா ஒன்றும் அவசியம் இல்லை. So this is your thermodynamics or second law. I'll okay. Usually in NEET level questions are from first law of thermodynamics. So say ஒரு closed loop இருக்கு. In this closed loop, Q is closed circular, I'm giving Q amount of energy. Okay, the closed loop, heat supplied. It does some work la. And the internal energy changes 0. So I can say that Q supplied is equal to work done, and my internal energy is equal to 0. Closed loop la. Okay, paka. Okay, fine. See, there is a process. Okay, this is your V, this is 3V, this is 2P, this is P. It's going in the way. Okay, fine. Okay, now when you see, you're supposed to find heat rejected during this cycle. Okay, இங்க பாருங்க, கேட்டோன்னே it will be super complicated. I myself I felt it was complicated, but when you konjam, if you put a little thought into this is a closed loop. In a closed loop, change in internal energy is 0, so you don't have any change in internal energy. Correct? Internal energy change irukadu. அப்போ ஒரு வேரியபிள் என்ன, the other variable is work done, so whatever work is done here, that's the heat rejected out. Correct? Yeah, simple. So these two processes are isochoric and isochoric, since there is no volume change, P del V is 0, work done is 0. Okay, paka. This is my, so and then so the only process which actually have some work done is this isobaric process. This isobaric, I'm just teasing you this stuff. Okay, this isobaric. Okay, so the work done is nothing but area is nothing but 2V into P, 2P into V. This is my work done. This work done is nothing but the heat rejected. Paka. I hope everyone's clear with this. Okay, thank you. Okay, this was a question in NEET 2012. That's good question they used to ask. Simple na, but konja thought you have to put it into it. Okay. Okay, this is konja complicated question. It's going from A to C. Okay, A B pathla pode and A C direct pode. Okay, fine, okay. And this is 6 kilopascals. This is 2, oh, 10 power 4 pascals. And then this is your cube. Your 4 into 10 power minus 3 meter cube. Okay. Now what I'm supposed to find is, see, the questions goes like A to C a gas is supposed to go. In the process AB la 400 joules of heat is added. In the process of BC, 100 joules of heat is added. Okay. Fine. Let's write this equation. Let's write this equation. For in process ABC, del Q is equal to 500. Okay. U is equal to, del U is del U is del U. Del W is equal to, which is the area under this thing. Okay. The area under BC is 2 into 4, 2 into 10 power minus 3 into 4 into 10 power 4. So 40 into 2 equal to 80 joules of work done. Work done is 80 joules. Okay. In the path lab, there is some internal energy change. Okay. There is some work done. Work done is nothing but the area under the graph. Area under the graph is full note பண்ணிக்கோங்க, because since they are in the same direction, this is in the same direction as this one, I can't take a negative here. I can't take this area of the triangle. Rather, I should take the entire area below this thing. Paka. So that's because that being the case, this is my internal energy. This is my work done. So the change in internal energy for this part is 420 joules. This is 420 joules. Okay. Paka, this is clear. There's another class which is supposed to happen. Okay. I'll finish it off. Don't worry. Like, this is all you wanted. In the question, if you solve now, you'll be able to solve every question. Basically, you have 400 joules input inga, 400 and then 100 again. So netta there is a 500 joule increase in total energy. Here there is no change in, there is no work done. So the entire thing is transferred as internal energy. Kata, you're able to get me, because the volume is constant. Inga there is some work done, and that work done is 80 joules. So only 20 joules gets converted into internal energy. So it's 420 joules. Okay, purida. 420 joules. Okay. Now what, if you may ask? Now since this internal energy change, we know this is constant. Okay, guys, I told you one thing and I made the exact same mistake. Yeah. I took the length as 4. But what did I tell you? The entire graph or length edukano. Correct? So it's 6 here. Maybe 6. 66. So it will be 120 joules. 120 joules. Paka. So my work done. So this is 120 joules. And my internal energy changes 380 joules of internal energy change. Okay, fine. இப்போ வந்து I'm supposed to find del Q for this process. AC. AC la del U is I know 380. Okay. I have to find del W with which I can find del Q. This is my del W in the area. It's nothing but this entire thing minus this triangle. The triangle like easy kandupidikalama. Triangle is nothing but half into base is nothing but 2 into 10 power minus 3. Height is nothing but 4 into 10 power 4. Okay. So 40. Yeah. 40 is a difference. So I remove 40 from 120. So it'll be 80. So my del W is 80 joules. So for process AC, del W plus del U is equal to my Q. Del Q is equal to 460. Now then this is 380. This is common. And since volume increase work done, so that's 80, which I found it out. So it's 460. This is your 2015 NEET question. Okay, இது வரைக்கும் சொன்னது போதும். Then you have processes. Okay, you have processes. கொஞ்சம் I'll discuss all processes. Let's start with isochoric. Very simple. Isochoric. Basically, isochoric is constant volume. When will you have constant volume? When will you have constant volume? When you have constant volume, you will have no work done. Okay, because P del V is 0. Okay, is constant volume. Then you have isobaric. It's in constant pressure. And then you have isothermal. Constant temperature. And then you have adiabatic. Here del Q is equal to 0. Okay, this is your basic stuffs. Okay, if you take a graph, okay, for isochoric எடுத்துட்டீங்கன்னா P V graph எடுத்தா it will be a straight line இந்த மாதிரி. There is no area under the graph, so there is no work done. Okay, paka. Here this is your isochoric. அதே வந்து if you take isobaric, pressure is constant. Pressure constant. Pressure அப்படியே சேமா இருக்கு. Fine. It has some work done. So isobaric la work done is positive. And then you have two curves, isothermal and adiabatic. So your isothermal la isothermal you have constant temperature. When you have constant temperature, PV is equal to nRT when T is constant, PV is constant. PV is equal to constant. So then their multiples are same, and then PV, then I can write as PV1 V1 equals to P2 V2. This is my isothermal. Fakka. Adiabatic if you take adiabatic is equal to 0. I don't have time to derive it, and it's also not necessary. Just remember what what it is. P V power gamma is equals to constant. Okay, fine. Okay, inga your slope is P by V. dP by dV is equal to minus P by dP by dV is equal to minus P by V. அதே வந்து in isobaric it's minus gamma P by V. So in adiabatic you'll have நிறைய ரொம்ப slope. Okay, so if this is your isotherm, what a plot there, this is your adiabatic. So in general, this is what your processes are. You have 4 types of processes in your 11th and 12th grade. Okay. Now there are constants for everything. Okay. For isothermal, for isobaric. Okay. Isobaric specific heat is Cp. For isochoric, specific heat is Cv. Okay. For isothermal, since there is no change in temperature, there is no specific heat. Okay. And then for adiabatic is kind of special. Okay. Adiabatic is special because see the concept is that you don't have energy change, so it's super fast. Say you have a piston and the piston ரொம்ப வேகமா அமுத்துற, in that case it won't have sufficient time for the energy to transfer only. Okay, the process is fast. That's your adiabatic. Paka. Okay, so yeah, I want you to remember few more things. ரெண்டு விஷயம். One is your work done in isothermal process, which is 2.303 into nr log base 10 V2 by V1. This is work done in isothermal process. Usually question don't come from this one, but தெரிஞ்சுக்கோங்க. And then you have another formula for work done in adiabatic. Okay, which is work done in adiabatic is equal to R by gamma minus. I could derive it though, but but still it's not necessary. By T1 minus T not. Yeah, this is your work done in adiabatic. Okay, so if you understand this thing, isobarically you have constant pressure, so you'll have some work done. Isothermally you have constant temperature, so you won't have any change in internal energy, so you won't have any change, so you don't use Cp, you don't have any change in temperature. Okay, அதனால you won't have any specific heat, because specific heat you want something. அதே if you take adiabatic la வந்து if you take specific heat na specific heat is nothing but del q by m del t. Since adiabatic has no del q, no heat supplied, del q is 0. So anything 0 by 0, anything divided by 0 by anything is 0. So adiabatic, your specific heat is 0. In isothermal process, since the temperature change is 0, del q by 0. Okay. Let me just write it. Your thing is del q by c del t. Okay. M del t. This is your heat capacity. Okay. இதில் வந்து adiabaticல this is 0 in adiabatic. Isothermal this is 0. So since adiabatic del q is 0, your specific heat is 0. In isothermal since Q is 0, specific heat is infinity. These are the entire thermodynamics chapter completed. But yeah, the second one is not necessary for second law of Shark's time. Okay, second law of thermodynamics வந்து அவசியம் இல்லை. It's required in your chemistry thing. Okay, so yeah, this is your entire thermodynamics covered. I think I've solved sufficient questions graph based panni, so I think it'll be really helpful. Okay, because I went in foundation level of, I started from internal energy, how it starts and all, and then I built it upon to graphical representation. I still have questions though, but the other class have started. It should have been started already. So yeah, thank you for watching, guys. See you tomorrow. Thank you so much. Bye.